Like at the beginning? I guess. And I said, hey.
That only brings up my Monday. I only do it like one Monday because I'm quarantining by the 25th, I think. So like by the next Monday. So I have like one Monday. I'm probably going to avoid scheduling on that day because every time I'm like, oh, I don't have to get good. I can hang out with people and hang out with people. I should just yeah, myself relax.
Okay. Got it. Sorry. No one talked to you. Right, look up this minute. You're okay. Okay, look. So this packet is the last homework packet you get for this unit. This is the first practice test packet. Practice test A, the yellow one. The blue one is practice test B. I give you 2 practice tests because I'm in the category of I like to get the practice test long before the actual test. I like to have as much time as possible to make sure I can do all of these problems. And more importantly, I want to make sure I understand all of these problems. So here's a big warning. The test itself is of the same format. There are 25 multiple choice questions in each of these practice tests. There's 25 multiple choice questions on the real test. However, many of these problems are simply repeats of homework problems because it is extremely difficult to find really good AP questions to have you practice. So what you're going to have to do, like I tried to find new ones, there just aren't any available that I can publish and give to you. What you're going to have to do is as you work a problem, you must force yourself to pretend that you've never seen it before. You have to think, okay, I've never seen this problem. If I've never seen it before, how am I going to be thinking as I solve the problem? If all you do is say, oh, I've done this one before, the answer is E, you haven't helped yourself a bit. All that will happen is on many questions on the test, you'll see a question and you'll say, these concepts are familiar, but you won't know what to do. Okay? So force yourself on the practice tests to make sure that you're understanding each and every question. To make sure that happens, I give these to you early. So giving them to you today. I don't give you anything on Friday. So no new packets on Friday. No new packets on Tuesday. No new concepts on Friday. No new concepts on Tuesday either. So Friday and Tuesday are simply your opportunity to interact with me and talk about any concept that you've encountered in the practice tests that you're like, this one I gotta have some help. Like I can't wrap my head around it. The idea is you are focused on understanding, not doing. Listen close. Unlike other classes, I don't create the real test by taking this test and just changing numbers. What I do is I made a separate list actually, and I said, okay, that practice test covers all of these different concepts. And then I went back to do AP tests from like 2013, 2014, 2015, 2016, and I just looked for problems and said, oh wait, that problem there, it covers these items. So I'm going to use that one on the test. I didn't even look to see if it even looked like anything in this. I just guaranteed that it covered the same concepts. So anyway, make sure you're focused on understanding the practice test. I also don't give you the answers because you want to practice the practice test like it's a real test. No answers, no notes, no help. And then I will provide a way through Canvas that you can grade the test and see your score, see which ones you missed. But you want to have that experience of it feeling like a practice test, not like a homework assignment. Questions? Oh, please.
So do we have to do the thing on Canvas?
Yes.
Okay.
Yeah, I want you to do that so I get some verification that you did it. That's
Okay.
all. So, and I'll try to remind you of that, Kate. So, anybody else? 2 points for Kate. Oh, please, I do.
Is this the only test for this term, or is this the big test?
Yeah, this is the test for term 1. Please remember, when we started the school year, I told all of you, look at me, that as long as you kept up with your homework, and as long as you were attentive, focused in class, and compliments to all of you, the class has been very focused and attentive. It's exactly what it needs to be. Most people have done a really good job of keeping up on homework. So because you've done that, you don't want to look at this, or this is, I guess, easier to see. You don't want to look at this test as though it is a like one-time chance, like high pressure. You want to look at it as, hey, I'm going to do all I can to prepare. I'm going to see how well I do. If I do well, awesome. If I don't do well, because you've been attentive and you haven't fallen behind, you're just going to come after school for a few days, several days, whatever it takes. We talk about why you didn't score as well as you should have scored. We figure out how to help you study more effectively, and then you just do it again. Different tests, but try again to see if you can prove that you understand the concepts. If you do better on the second test, we pretend the first test didn't happen. So, questions about the test? Okay, one other thing, because I start this test prep process so early, I give you the practice test really early. You have 2 full days in class to discuss the practice test. I have videos from 2 years ago where I actually, as I was interacting with students after school, I recorded my solution to almost each and every problem. I'm going to post those on Canvas. So you have that as a resource. Because of all that, no questions on test day. Like the day of the test, you can't ask me anything. You just come in, you sit down, you take the test. It's like college. You don't say, what about this, what about that? No, you just take the test. So. Question, please.
Do we have to take it all in one period? Like if we don't finish, what happens?
This one does have to be finished in the period, but I can tell you that based on previous years, you'll be fine for this one. You don't need to rush, just come in, start right at the bell, you'll be fine. But yeah, you do have to finish before the bell for this test. Points for Dave, anybody else? Please, Nick.
It's all like multiple choice, right?
So the format is identical to the 2 practice tests. 25 questions, every question is multiple choice. The actual test I'm giving you, I believe every single question is an old AP question. Maybe a couple I invented. But
are you like graded on like say you were to go back on a question you got wrong or something? Are you graded on like showing your work and like you can explain why this is the answer, or just simply the answer itself?
No, good question, Mitch. So for this test, it is graded just like the AP test is graded, in that you have 25 questions and it's all or nothing. So no, you can show work if you want, but it doesn't count for anything. The way this test will be graded is 25 questions. I'm going to make the test 100 points. So normally that would mean each question would be worth 4 points, but I offer a bonus. Okay, the test bonus is if you take the test on the date it is scheduled, then if you miss a question, instead of losing 4 points, you only lose 3 points. So your score would be 97 if you miss 1, 94 for missing 2, 91, etc. If you don't show up on the day of the test, you don't get the bonus. So then you lose 1 point, you lose 4 points for each wrong answer. So your score drops like this. Okay, please, Kate.
So if for some reason any of us get quarantined, does it just take it the same day?
No, sorry. Look at me. So the bonus is there just to prevent people from waking up the day of the test and saying, oh, I just didn't prepare how I should have, not coming. That's when you lose the bonus. If it's due to illness, quarantine, a school excused activity, even a family excused activity, for the things you can tell me ahead of time, as long as you tell me ahead of time, like I've already had a couple of students come to me and say, I have something scheduled that day, I won't be here. They just schedule with me when they're going to take the test, and then it's fine. Quarantine or illness is an emergency thing, so we'll work that out if that happens, so no worries. Yeah, the bonus isn't a penalty for sickness, things like that. It's just trying to prevent you from procrastinating, so. More for Kate. Anybody else? Awesome. On the day of the test, I rearranged the room. The desks are spread out. I use dividers. You just pick a desk, you sit down, you just go to work. So no questions or anything, you just go to work. No calculator, no notes on this test. It's all just like the practice test. Okay, cool. So that's the test. Let's look at the pink packet today. That's the homework for today. Again, no packets after today. And the day of the test, I don't give homework either. It's just a day to take the test, and then you're done. So. All right. Go to number 2. Okay, number 2 doesn't really contain any new ideas. Number 2 simply has some new notation. So we've been talking about how you can have a function called f. You can have the derivative of that function called f prime, and the second derivative of f called f double prime. Another common notation you must get used to is this one. They'll sometimes say you have a function and it's just y equals, and then they'll give some sort of formula for the function, I don't know, whatever. Okay, so this is taking the place of f. It really means the same thing. They're just calling the function y instead of f of x. But that means they can call the first derivative. So we got our function. The first derivative will be known as y prime. The second derivative is y double prime. So that's a notation you'll see sometime. Another notation you'll see is we call the function y. The first derivative is the change in y divided by the change in x, because that's what a derivative is. You saw this on a previous homework. The second derivative, this was also on a previous homework, looks like this. So in this problem, they're saying, hey, we're showing you what y or f of x looks like. We're telling you the first derivative is always positive, and the second derivative is always negative. So Danika's chart, the first derivative is always positive. That means my function's always going up. Second derivative always negative. It means my function is always concave down. Questions so far? So talk to each other and solve that problem. Raise your hand when you have it. Go. Oh, please, Abe. Are you ready to go? Cool. Go ahead and talk all you want. Just show me your hands when you're ready.
We only want the first and the first and the second, not the third.
Who's got a hand? Show me. Always remember, far better to raise your hand and be wrong than to not raise your hand. I promise. Like you just having the, courage to say, I think it's this. Turns out to be wrong. Who cares? Well, it is just to keep learning. But when you make the effort, it does make a huge difference. So hands, who's ready? Natasha? This one here?
Yeah, sorry, I was just looking better.
No, B is correct. I was looking in the wrong place. So Natasha votes here. Raise your hand if you agree with Natasha. 2 points, 3 for Natasha. I noticed that the function is increasing for all of this time. But I'm supposed to find out where the function is both increasing and concave down. This section is concave up, so it's only this section that is both increasing and concave down. Please, Brian.
So can we just assume that B is at the point? Is there any way that we can tell without seeing the question at the point?
Oh, awesome. Two points for Brian. 3 actually. No, really good question. Basically, from the fact that they only allow me to answer in one of these 5 ways, they are expecting you to make that assumption. No, without, otherwise, there's no way to really know that B is exactly the inflection point. It's just because that was the only one that fit the answers. Perfect. Anybody else? Cool. Next one. Okay, a couple things to add to your notes. Make sure you have this memorized for the test. Remember, I was helping someone today, and literally they got the wrong answer simply because they read too quickly. Don't read quickly, read slow and careful. It says a polynomial. I stop right there. I need to remember why they're telling me it's a polynomial. Here's why. We talked last time about the fact that if a function has a discontinuity, then at the discontinuity, you can't find the tangent slope. So if the function is continuous, I can find the tangent slope. Discontinuity, I cannot. Also, if the function has a corner, I can't find a tangent slope at a corner. I can't find a tangent slope at a vertical tangent. Vertical tangent has an undefined slope. So we talked about that last time. Those 3 words can be grouped into another word known as differentiability or differentiable. So you need to memorize that a function is only differentiable at points where the function is continuous, at points where there are no corners, and at points where there are no vertical tangents. At any point where a function has a discontinuity, corner, or vertical tangent, the function is not differentiable at those points. Not differentiable means you can't find a tangent slope at those points. So make sure that's memorized. Please, Kate.
But can't a function not be a polynomial though?
Oh, for sure.
So then what does it have to do with it being a polynomial?
Perfect question. No, really, perfect. The reason they tell you it's a polynomial is all polynomials are continuous and all polynomials are differentiable.
Okay.
So they're telling you in one word all of this information. The function's continuous, it's differentiable, therefore it doesn't have any corners or vertical tangents. So it's their way of testing to see, that's a perfect question, Kate. It's their way of testing to see, can we give you one word and convey all of this information? Have to know that for the test. Questions? And again, on the test, it's not like they're going to ask you, what are the characteristics of a polynomial? They just throw the word polynomial in, and as you're solving the problem, you have to remember these things to help you figure out the problem. Next thing they ask, they say this function has a relative max at -2, 4. I do a lot of problem solving without grids because I got really frustrated that when I would try to draw the grid, I'd go like this, and I'd start counting, and sure enough, I made it too small or too big. It didn't fit. I'd have to erase this and try again. So I learned in AP Calculus that often the grid is irrelevant. I just need to know where the points are. And they don't have to be perfect. I'm just trying to think. So I just go like this. -2, 4. At that spot, this function called p has a relative max. So I remember from my white sheet, that means p is going to do this. P will change from increase to decrease at that spot. I know p can't do this because that would be a corner. P is a polynomial, no corner. Come on. Question. Please, Logan.
Oh, wait. I was looking at the notes.
You're good. So then I keep going. Relative min at 1, 1. So that'd be over here somewhere. That will be where p goes from decrease to increase. Relative max at 5, 7. So that's over here somewhere. Question?
So what does relative maximum and minimum?
Say again.
What does relative maximum and minimum mean? Because it's not,
Go ahead.
it's like, because it's not, because it said like, oh, 4 is, but then there's one higher at 7, so does it just mean whatever it's closest to, like it's the highest closest?
No, it's the strict definition, 2 points for Ella. It's the strict definition on your white sheet. The white sheet says this function p will have a relative max where p changes increase to decrease. So relative max has nothing to do necessarily with being highest.
It's just the point where like the tangent slope would be, like it's the highest.
It's,
In the curve, in that curve, it's the highest.
I wouldn't even necessarily memorize it that way, to be honest. Although it is. I would just go with the strict definition, which is p has a relative max when p changes increase to decrease. That's all I'm looking for. So yeah, right in that one little spot, that is the highest point. But I still just look, I don't remember that because that can cause a problem with some AP questions I've seen. I just remember it's the point where p changes increase to decrease.
Okay, so it's a more specific version of like an inflection.
No, don't put those together. Inflection point and relative max, I wouldn't want to put those together. Like some of the patterns you're seeing are sometimes present, but because they're not always present, not a good thing to memorize in my opinion. So just memorize this one. When the function changes from increase to decrease, that's where p has a relative max. So that's what I've shown. 2 places where p changes increase to decrease. 1 place where p changes decrease to increase. 2 more for Ella. Questions? Cool. Next thing right here. Look. Okay. This is a really good example of an AP question where you've got to make sure that the words make sense to you. Like 2 more for Ella. You have to keep digging to say, this makes sense. I'm not just memorizing steps. I'm understanding what they're talking about. It says P has no other critical points. Look at the white sheet. The white sheet says P will have a critical point where the tangent slope of P is 0 or undefined. So right here, the tangent of P has to be 0. Right here, the tangent slope of P has to be 0. Same thing here. Tangent slope of P has to be 0. Those 3 are critical points of P. P has no other critical points. So P will have no other places where the tangent slope of P is 0 or undefined.
So those are all critical points.
2 points here. Everyone listen to this comment. Look at me. Practice something. 2 more for Logan. Practice in this class never saying the word critical point alone. Never say the word inflection point alone. Never say the word relative max alone. It's always got to be in combination with something else. So I can say these 3 are critical points of P. But I've got to have that extra statement, otherwise the word critical point doesn't make any sense. So those are definitely critical points of P. Question. And then the second thing you've got to know is why can I say that? It's on that white sheet. These are critical points of P because these are points on P where the tangent slope is 0. It's the why that you need for this test. You have to know the why because you're getting brand new problems that will look very different. Question. Cool. Let's see. How many zeros does P have? A 0 on P is where P has a y coordinate that is equal to 0. Next key thing. We said to Kate, another point for her, that polynomials are always continuous. They're always differentiable. You should also memorize that all their derivatives are also continuous and differentiable. So this graph has to go from here to here. Let's try this. So there I connected them. But that's wrong. Raise your hand if you know why that's wrong. Like the graph cannot connect like that. Why not? Curtis. Perfect. Actually causes 2 more. Because they have 2 more spots where the tangent would be 0. But there are no other critical points, so I can't connect like that. How many saw it? Points, 2 for Curtis, sorry, 3 for Curtis. How about this one? Why can't I say, oh, it's just going to jump? I'm just going to go from here to here. Hands, why not? Stephen. It's a polynomial has to be continuous. Can't do that. How many knew it? 2 more, 3 for Stephen. So, I know it's got to go like this. Somehow.
There is a loop-de-loop about that.
What's that?
I made a joke about how there is a loop-de-loop though, so you have to remember. And then I told myself it's not very funny now,
Yeah,
but I mean it wasn't funny then. It just wasn't fun.
Okay. So this function has 2 zeros, 2 places where the y coordinate would be 0. Question? This is a superb example of what you should expect on the actual test. Something that talks about stuff we've talked about, but the problem itself doesn't seem familiar at all. Like I've looked at hundreds of AP questions. There's never been one like this ever again. Like they dreamed it up in 1988, and then that they don't use it again. They come up with new things. Logan. If it wasn't a polynomial, no, then you can't really answer because there's too many other things that could happen. Good question. Please.
Why are there 2 zeros?
So, are you okay that the graph of P must look like this?
Yeah.
Awesome. Are you okay that this would be the rough approximation of where the x-axis is located? What's the y-coordinate here?
0.
Good. What's the y-coordinate here?
0. Oh.
You good? That's a good job. No, just keep talking. 3 for Spencer. That's what you have to do. Anytime in class where you're like, wait a minute, I don't see it, don't even worry. Just speak up. We talk about it for a minute, then you go, I see it. Once you see it, you'll remember it. Until it makes sense, it's hard to remember. So. Questions? Next one. Okay, you're going to do this one at home, but I just want to point something out so that it's not confusing. Some people in past years have said to me, I don't understand. Right here it says f prime equals, And then here it says f prime equals again. Like, why in the world did they say it twice? Well, they really didn't. What happened was, I wanted you to be able to work this problem, but I am trying to save you time whenever I can. And so I thought, I don't really want you to have to pull out your calculator, so I'll just do it for you. So I provided the graph here. Now you can answer the problem without picking up your calculator, because the whole test is non-calculator, but this one would actually require a calculator, so it just makes it so I can make it a non-calculator question. Questions about that? So you'll do that at home. 5 is kind of the same idea. There's lots of others. Go to 8.
I do
Go
have a
ahead.
question about
Please.
the last one. So for the questions that are like f prime, are we finding f on that one?
Which number?
The number 4.
So there are lots of questions in the packet, lots of questions on the test, where they give you one of these, but they ask you about one of the others. Really common. This one, you are correct. They're giving you this, but they're asking you about this.
Okay.
Yeah, that's why I always read slow and careful. 2 more. Okay, go to number, what was it, 8? Raise your hand when you have the answer to 8. I just want to make sure we can do it. Go. Feel free to talk to each other, that's fine. And you keep your hand down for a minute, I'll call out. It gets, I don't mean to make you feel tiresome by holding your hand up for minutes on end. Sorry. Question is ready. Let's wait a second. Okay. Who's ready? Show me your hands. Let's go another minute. Show me your hands again. Who's got it? There we go. Let's go, Blake.
So I did B.
Blake votes B. Raise your hand if you agree with Blake. 2 points, 3 for Blake. It says this is F. He wants to know, where is F not differentiable? We just put on the board that F is not differentiable at any point where F has a discontinuity, like this jump, or at any point where F has a vertical tangent, like this spot that they mentioned, or any place where F would have a corner. This graph does not have any corners, so the correct answer is definitely B. And again, the key is you understand why that's the correct answer so you can apply that concept in the future. And the thing you've got to remember is this problem uses a graph and it's testing you on, do you understand what differentiable means? That doesn't mean on the test they'll necessarily use a graph to test you. They may test you in a different way about differentiability. You know, they did that here with just words. There was no graph at all. This one here, so. You don't really know what you're going to get, so that's why you just have to understand the idea. So. Next one. Go to number 9. Okay, number 9 has 2 tricks in it. The test writers are always trying to fool you. The first way that they fool you is as follows. Let's do a little extra credit thing. You don't need to show your hand like this, just show it like this. That way you don't feel like you're, I don't know, sometimes it's safer just to show me, not everybody else. As you read the problem, would you say so there's no label up here. As you read the problem, would you say they're giving you a graph of f? If you think that's the case, you're going to go like this. So you look at the problem, you read it, just pretend it's a test, you've never seen this before. If as you read, you're like, oh, this is a graph of f, you're going to go like this. If as you read, you think they're giving you a graph of f prime, because there's no label, there's just words, you're going to go like this. If you think they're giving you a graph of f double prime, you're going to go like this. Show me your vote. So are they giving you a graph of f? Graph of f prime, f double prime. Show me. Everyone give yourself 3 points for voting. When they say the graph of a twice differentiable function f is shown, they're giving you f, and they're telling you that f is twice differentiable. What that means is that on every point on f, you can find a tangent slope. And if you took all those tangent slopes and created a plot of f prime, at every point on f prime, you would also be able to find a tangent slope. Therefore, f is twice differentiable, because I can go from f to f prime successfully, and from f prime to f double prime successfully. That makes f twice differentiable. Yes. Hey, 3 for Charlie. Memorize. All polynomials are continuous and differentiable, and so are all their derivatives. So yeah, polynomials is like twice, triple, it just goes on forever. Yeah, for sure, twice differentiable. Twice differentiable means you start with some function, you can find every tangent slope of that function. That's once differentiable. If you then take all those tangent slopes and plot f prime, then you find all the tangent slopes of f prime to create f double prime. Now you're saying that f is twice differentiable. Okay, 2.
How would they word it if it was f double prime? Or f prime?
Oh, they would just say this. Oh, perfect. 2 points. Look. They would say there's lots of different ways. There's a few different ways, but one way is this, Kate. The graph of the second derivative of f is shown.
Okay.
That would mean this is f double prime. Anybody else? Okay, so that's f. Here's the second trick. You'll find that throughout the year, I try to give you as many AP questions as homework as I can. And I try to give you tests throughout the year where every question is an AP problem as much as I can. I do that because succeeding on the AP test is more than just knowing calculus. Succeeding on the AP test is you have to know the test. You get to know the style of things they do. Here's a good example. You see a bunch of answers in this format. It's not guaranteed, but it's pretty safe that what they're looking for is one of these things is negative, one of them is 0, and one of them is positive. And you have to figure out which is which. That's what they're looking for. So as you look at this picture of f, please raise your hand if you can tell me, is f, the 0 is the quickest to find. Is f of x f of 1 equal to 0? Is f prime of 1 equal to 0? Or is it f double prime of 1 that's equal to 0? Show your hands. Which one of those? Because that's what they're asking. They're saying, put these in order from least to most. So therefore, the first one's likely to be negative. Second one's likely to be 0. Third one's likely to be positive. These are only 3 choices. One of those is most likely going to equal 0. Which one is it? Pen. Which one is equal to 0? Go, April. Say it louder. This is f. This point right here is at 1, 0. That means f of 1 is definitely equal to 0. How many knew it? 2 points, 3 for April. Questions? So really, the only possible answers are C and D, likely. Like, they could have a problem where it's like negative, negative, positive. They just never have. Maybe they'll do that this year. I don't know. So go looking for the other one. F prime means the tangent slope of F. So I come right here and say, what's the tangent slope going to be right there? Or in other words, what's the tangent slope of that line? So just say it out loud. Is that tangent slope positive or negative? Say it. Positive. So that means F prime is positive. Question. This is a graph of F. This graph of F is concave down. If F is concave down, every y coordinate of F prime will have a negative value. Therefore, F double prime of 1 must have some negative value. Question. This is, I believe this problem is on one of the practice tests because it's such a good problem at forcing you to make sense of several things. Just again, make sure on the practice test you don't say, oh, I remember the answer is D. That's useless. The whole idea is to understand how you got these. Question. Cool? Number 10. This is graph of F. Which of the following statements about F is false? Just say it out loud, true or false. Is F continuous at x equal 8? True or false? Say it. False. False. Questions? Remember that a graph is really just a bunch of dots. Every dot represents x and y. So they're just saying, you know, put a, I don't know what number that is, we'll say 10. That means that dot is at a comma 10. It's just an xy pair. Yeah, it's a removable discontinuity, but it's just an xy pair. 2 points.
I'm confused by relative maximum again because it says that it is a relative maximum as x equals a, but it's not changing from increasing to decreasing.
So try this. From this point to the next point, is that an increase or decrease?
An increase.
Next one?
Increase.
Next one?
Increase.
So what we have to do is pretend that we can actually find the last dot here. Where's the very next dot? It's up here. Is that an increase or a decrease?
An increase.
Where's the very next dot?
Oh, okay.
Do you see it?
Yeah.
Yeah. No, 2 points for Ella. That one fooled me as well, Ella. The first time I read it, I'm like, that's not a relative max. But it is. So, because it fits the definition. The graph of F is changing from increase to decrease. Anything else? Please.
Are corners also considered relative maximums and minimums?
Not necessarily. Like here's a corner. Close. Quit. There we go. Here's a corner, Kate, that is not a relative max or relative min.
But if a corner is like changing from increasing to decreasing, it still is relative.
Right.
Okay.
That's why I say, no, 2 more. So I say, don't look for a new pattern. Because if you just stay with the definition, F has a relative max. When F changes, increase to decrease, can't go wrong. The corner's like, well, sometimes, but not always.
Yeah.
Oh, please.
So is a removable always a maximum or minimum?
Not necessarily. Two more for Luke. Because a removable could look like this. No other dot. Yeah, that's still a removable discontinuity, but it's not a relative max or a relative min. Some more? Okay. Don't forget domain, just reviewing from previous classes. The domain of f is the list of all x's for which there is a y. That's the domain. All the x values that have a y. So at x equal a, there is a y coordinate. Hence, a is in the domain of f. So that's just a quick review from previous classes. Go to 13, just scratch 13 off. Don't do 13. Don't do 13.
Why is it broken?
No, 13. Okay, every year the AP test writers, like to get a 5 on the AP test, if you score about 66%, you get a 5. Okay?
Wait, that's not how that works.
Oh, yes. If you score about 55%, you typically get a 4. 44% is about a 3.
So this test must be fucking wild, right?
Yes.
This is the most crazy test.
But because of that, there are questions on the AP test that, as a class, it might take us an hour to get everyone to go, oh, now I see it. Like it takes just, you ask me, I talk, you ask me, I talk, like back and forth for an hour. That's this. So we're going to ignore it for now. Don't worry about it. It's not something you have to worry about for this upcoming test.
So if I get like a 94 on this test, I just get to skip college, right? Like I just win. Like I won, right?
Well, you know.
What if I really want to do number 13? What if I want to try it?
You can try it. I won't help you right now because it takes too long.
Okay.
Sorry. Okay, you're going to do this one at home, but I just want to point out one thing that people often make a mistake with. So I'm not going to do this for you. I'm just going to point out one thing they often make a mistake with. They go right here. Remember a few minutes ago I said, look, don't ever say critical point without more information. Critical point alone doesn't mean anything. The same thing as differentiable. This is talking about f being differentiable, or not differentiable. Well, we know f is not differentiable at points where f has a discontinuity, corner, or vertical tangent. So what a lot of students do is they look at that graph and they go, bam, right there. Yeah, that's the correct response. It's a corner, so they say, oh, that's the answer. No, this is a graph of f prime. I never said that if f prime has a corner, that has anything to do with f itself. That's f prime having a corner. So when f prime has a corner, go ahead, April, please.
Well, when you were talking earlier, you said that if the first graph is like continuous, does that mean all of the graphs are?
Oh, no. So what we said is a polynomial is continuous, and all of the polynomial and differentiable, as are all of the polynomial's derivatives.
But if you have like if the first graph is continuous, not all the rest of them are? Like,
Not necessarily.
Okay.
Yep, perfect, not necessarily. So this graph of f prime, I cannot find the slope of f prime at x equal -1 due to the corner. That means on f double prime, there's a missing point at x equal -1. Therefore, f prime, look close, f prime is not differentiable at that corner. F prime is not. That's not what they're asking. They want to know if f is not differentiable. Well, the y-coordinates of f prime are the tangent slopes of f. So right here at x equal -1, there's a point. The y-coordinate maybe is 2, I don't know. That means on f, the tangent slope at x equal -1 is 2.
There was a tangent.
There was a tangent slope on f. F was differentiable. We found the tangent slope of f. That's why this is a false statement and not the correct answer.
Okay, wait, you lost me at the end. I'm sorry. I was there for most of it.
You're good. The key thing to notice is this is a graph of f prime. The dots you see, each one of those dots, the y-coordinate tells me the slope of f. So I can tell you when x equals 0 on f, the slope is 0. When x equals 1 on f, the slope is 2 on f. That means I was able to find the slope of f at every point.
Okay,
Therefore,
now
f
I get
is
it.
differentiable.
Yeah.
There we go. 2 more. Don't stop asking. Okay, we got 90 seconds. Go to number. Here's a challenge because class is too short. Last year we had 16 more minutes, 15 more minutes every class period. So go to number 23. Go to number 23. To save time, I'm just going to leave the writing from last period. You're going to want to memorize this. You don't have to memorize it word for word. You have to memorize the idea. This class is not about regurgitating. It's about understanding. F, yeah, that sounds terrible, regurgitating. F is concave down. So this is more like if F is concave down, then both the tangent slopes of F and the secant slopes of F, they will decrease in value as you follow the graph of F from left to right. So as you look at the graph, you're going to follow the tangent slopes or the secant slopes. You'll see them decreasing. Let me demonstrate. This problem gives us 4 different possible tables that represent F. They tell us that the F has a positive first derivative, negative second. So Danika's chart says, oh, I'm looking for a positive first derivative, negative second, so F should be increasing and concave down. Got 1 minute. No, we got 15 seconds. These functions are increasing because the y values go up. These don't. So it's A or B. Don't leave on the bell. Watch. Now what I need to check for is the concavity. I check for the concavity by checking the slopes, the secant slopes. From here to here, the y-coordinate changed by 2. The x-coordinate changed by 1. Here to here, y-coordinate changed by 3, x by 1. That's the wrong way. That's the slope going up. I need the slope to go down. Good work. See ya. So secant slope is a slope from point to point. Tangent to slope at a point. So I just check the slope between those 2 points.
Oh, they were the same.
We're going the wrong direction. So the slope between these 2 points is 2 over 1. The slope between these 2 points is 3 over 1. Concave down means those slopes have to go down. They have to decrease.